Your definition of compound. This is my definition of compound. It's substance formed when two or more elements combine chemically. I want you to focus on that top one, not the bottom one. For now, we're going to talk about the bottom one in a minute. It's when a substance formed when two or more elements combine chemically. It's a compound. We do have something called the law of constant proportion, which is an early chemistry law. It tells us this, that elements in a compound always combine in the same ratio. So every time you have water, it's going to be the same compound formula, the same ratio. Do you remember water's formula? H2O. So what does the 2 mean? Are there 2 hydrogens or 2 oxygens?
2 oxygens.
It's 2 hydrogens. You got H2, the little bottom down 2 is talking about the hydrogen. It's got 1 oxygen, H2O. There's always 2 hydrogens to 1 oxygen. The law of constant proportions holds true. But anytime you have water, it's 2 H's and 1 O chemically bonded together. There are smaller and larger compounds than that. There's compound that's C6H12O6. It's always got 6 carbons, 12 hydrogens, 6 oxygens in this big molecule. Sugar. There's smaller ones than that, like just oxygen gas, O2. It's just 2 little oxygen molecules. I guess that's the smallest, 2 molecules together, or 2 atoms together. 2 atoms to make 1 molecule. That'd be the smallest thing. Everybody get that?
Nope.
So slow already. All right, I'm moving. Here we go. Speaking of oxidation numbers, did we already define oxidation number yet? Oh, we skipped a spot for oxidate. No, we defined it, right? Okay, I have the slide again. We don't need it again. Yeah, it's the overall charge on the of the ion after it's lost electrons or gained electrons. Maybe you can just find it by looking at what group it's in. Okay, that's that. I don't really want to do that right now. We have 2 kinds of chemical bonds. The first kind of chemical bond that I'll talk about is the covalent bond. Let's break that word down real quick. Wow, you guys get this note down, then I'll break it down. Covalent bonds are formed when atoms share electrons in their valence shell. It's possible for atoms to sidle up next to each other so close that they'll actually share an electron, and the electron will live in both atoms' valence shell at the same time.
So what do you write this out?
Right where it says define covalent bond.
But that just says covalent.
Yeah, but here's the definition. It's formed when atoms share electrons in their valence shell. Okay, let's break that word down. What's the prefix on this word? What does co mean?
Chair.
Together.
No, it's like
It's like together. Cooperate, commingle, comrade.
Whoa.
There's lots of different things that means together. Like co-op, cooperative, co-op playing. That's together. Valent, what does that look like? Oh, so it's together valence shell. It's sharing a part of your valence shell. That happens. Water is a covalent bond. We'll talk about covalent bonds next week. This week we're going to talk about the simpler, easier to understand ones. Yeah, Garrett, do you have a question?
does that mean that that ionic one is going to be like more parasitic, like it rips the other from?
Look at you making a prediction. That's pretty right. Ionic bonds are formed when atoms transfer electrons. It's going to be much less even. It's not a share. It's more like one element's going to give up an electron And then the other element is just going to take that electron and be like, thank you very much. For our purposes here in ninth grade, we're going to talk about these as separate types of chemical bonds. In reality, it's a spectrum. There's kind of like gray areas. Some are more evenly shared. Others are shared but not evenly. Some are like really not even. It's like ionic. He has the electron, he doesn't. But for ninth grade, we're going to be like, yeah, atoms can share electrons in the outer shell, or sometimes they'll just like give the electron, and this one has lost it, and this one's taken it. We got it? I see a couple people writing. I'm just itching to go fast. Is there one more note on there? Oh, yeah, okay. So atoms are going to form these compounds. They're going to like partner up together. But then the thing with compounds is the overall charge is always going to be neutral on a compound. The charge of a compound is going to be neutral. That's our answer for that. And then underneath it says to explain. Yeah. How can we explain that? The overall charge on a compound is always going to be neutral. How the heck do we explain that?
Because the amount of protons and electrons doesn't change. And they're both neutral.
I've never even said it that good, but I like that. The total number of protons and electrons, we're always going to start with atoms that are neutral, right? And so the total number of protons and electrons won't change. They'll just kind of like trade between each other. So the charges will cancel each other out. How many lines do we have to write that in there? Oh, God.
It's like total number of particles doesn't change.
If that makes sense for you, you can say that.
Yeah.
I'm going to say, okay. So total number of, I'm going to abbreviate protons and electrons will be equal. So charges, and I'm going to say charges, and by charges I mean their oxidation numbers. Oxidation numbers will cancel each other out. One way to think about this is if the charges haven't canceled each other out yet, they're still trying to do chemistry and they're not done reacting. And they're ready to do some reactions. If they still have a charge, and they're like, can we get an electron, or I have this extra electron, let me get rid of it. And they'll like try to continue the reaction. And then once they've formed a compound, it means all of that has balanced itself out, and now they're neutral. Yeah, what
What does that say after the
total number of, yeah, that is a good question. I did P positive, which stands for protons, and this is my really crazy and sign, E negative, which stands for electrons, will be equal. Oh, wow. Yeah, let's do this. Let's right away just flip pages, and I'm going to teach you the shortcut for making something called Lewis dot structures.